Today we will be discussing job order costing. Job order costing is a method used to determine the cost of jobs or orders that are customized and made specifically according to a customer's preferences. Examples include customized products such as jewelry, t-shirts, or signs, as well as construction projects or even medical services. Consider the example of a company that makes customizable t-shirts. Each job would consist of a batch of t-shirts made to order. One order could come from a 5K race that provides shirts for all race participants. Another order could come from students in an elementary school who need matching t-shirts for a field trip. You can see how each order or job will need to be customized to the customer's needs. Jobs come in different shapes and sizes and therefore will carry different costs. A job order costing system keeps track of all the costs that go into each job, which include direct materials, direct labor, and factory overhead. These would typically be recorded on what is called a job cost sheet. The direct materials and direct labor related to a job are relatively straightforward to track and assign to a job as long as the company stays organized. Simply add up the cost of all materials and labor that went directly into the job, such as the fabric used in the t-shirts and the wages of workers working directly on t-shirts of a specific order. The factory overhead can be a bit trickier to calculate. Factory overhead consists of indirect costs that contribute to many or all of the orders that a company completes. Take for example the rent on the building where the t-shirts are produced, which is one example of a factory overhead cost. Let's say that the company incurs $1,000 in factory rent this month. This cost has to be paid to fulfill the first order of 5K race t-shirts, but this cost also is needed to fulfill order number 2 of elementary school t-shirts, as well as orders 3, 4, 5, and any other orders in that month. Let's say that there are 5 orders in total. So we need to create some kind of procedure to allocate the $1,000 rent cost to the 5 orders. A naive approach might be splitting the rent equally to the 5 orders. 1,000 divided by 5 orders is a $200 allocation per order. Each order absorbs $200 of the rent cost. The problem with equal allocation is that some orders are much bigger than others, and it therefore makes sense to allocate more factory overhead to those jobs. The 5K race might require 500 t-shirts, whereas the elementary school might only need 60. Allocating $200 of overhead to each of them wouldn't be fair. A better approach is to assign overhead costs based on a predetermined overhead rate using what is called an activity base. This is just a fancy term for an activity we want to link to factory overhead. Take for example the common activity base of direct labor hours. If we use direct labor hours to assign overhead costs, more labor-intensive jobs would be assigned more overhead costs. We use the formula predetermined overhead rate is equal to the estimated overhead costs divided by the estimated activity base. We use estimated numbers here as the overhead rate is predetermined, that is, we decide on it before the period even begins. So let's assume we want to allocate $1,000 of rent, and we want to use the activity base of direct labor hours. If we assume there are 500 direct labor hours this month, the predetermined overhead rate is $1,000 divided by 500 direct labor hours equals $2 per direct labor hour. That means for every hour of direct labor that a t-shirt order requires, we should assign $2 in rent cost. In many examples, we will be using total overhead costs as the numerator to this equation, but I'm focusing specifically on rent costs to make the example a bit more concrete. So if we return to our 5 t-shirt orders, and we know how many direct labor hours each order has, all we have to do is multiply by 2 to get the factory overhead costs. So if there are 100 direct labor hours for order 1, 100 times 2 is $200 of rent allocated. And if there are 75 direct labor hours for order 2, 75 times 2 is $150 in rent allocated. And the same procedure applies to the remaining orders. Now we are assigning more of the rent costs to the orders that require more labor, which makes a lot more sense than the equal allocation procedure that we explored earlier. Note that if we add up the direct labor hours for each order, 100 plus 75 plus 150, etc., we get our direct labor hour total of 500. And if we add up all the rent allocation of each order, we get the rent total of $1,000. Note that as we use estimated overhead in our calculations, most of the time the allocated overhead won't be exactly the same as the actual overhead. We will explore how to deal with this situation in the next video. Alright, that wraps up everything I want to talk about in this video. Join us in the next video for an applied problem where we look at some of the journal entries.